Hello everyone, welcome back. Here is Ali Talabi and this is module 13. And this module will talk about CAPM. So let's review some major notes and then we'll talk about questions. So we talk about the capital asset pricing model and we learned that under CAPM we are using beta coefficient to measure the risk. The relationship between the risk and return when you're using the beta is indicated in security market line. So SML shows the relationship between the beta and the expected return graphically. So that's a line. So we already talked about the CML or capital market line before. What's the difference? In capital market line, we use the standard deviation to measure the whole or total risk. However, remember when it comes to the SML, we use beta coefficient, we just measure the systematic risk. So it doesn't include the total risk, it just focuses on systematic risk because the assumption here is you were able to diversify your portfolio, so you were able to eliminate the non-systematic risk or the unique risk as well. So we focus on beta later and we mentioned that it actually measures the magnitude of the stock return changes due to the market return changes. So you have two variables here, independent variable, which is your market return, and dependent variable, which is your asset or stock return. And you want to see how well these two variables are moving together. When you're talking about the beta of 1, it means your asset is moving in the same direction, same magnitude of the market. Also, we talk about the risk-free asset, and we mentioned the risk-free asset have a beta of 0 because it has nothing to do with the market return changes. So it's a kind of uncorrelated. So the beta should be 0. And we also argued that it is possible to have the negative beta given the fact that some stocks or some assets are moving in the opposite direction of the market. We mentioned, for example, for the gold stocks, most of times investors are using them to hedge against fluctuation and the downturn in the market. So those stocks, they have the negative beta. We also talk about the risk premium. You have to be careful because that's a very common mistake. Many of my students, they get confused between the market risk premium and the stock risk premium. So whenever we talk about the risk premium, that's the difference between the return and the risk-free rate. Now, if you're talking about the market return, it is market risk premium. So the market risk premium, that's the difference between the market return and the risk-free return. If you're talking about the stock risk premium, you're talking about the difference between the return on a specific stock and the risk-free rate. Also, we talk about the alpha, and alpha measures the difference between the expected return based on the CAPM or based on what the model is actually estimating and the actual rate of return. So if you draw the line and if you are above the CAPM, it means that the stock is undervalued and the alpha is positive. If you are below the line, below the CAPM, it means the stock is overvalued and the alpha is negative. If you are just on the line, it means that the alpha is 0 and the stock is correctly priced. Now, let's look at the questions from this module. Here is the first question. We talk about the CAPM and we learned that based on the CAPM, the expected return for any stock should be the risk-free rate plus the market return minus the risk-free rate multiplied by beta. We also call this RM minus RF, market risk premium. Now, let's based on this argument, let's see that actually which one of these options is reducing the expected return. So the point here is I want to see that if this is my expected return, which factors actually will lead to the reduction in expected return, which changes. And the assumption here is the beta is less than 1 greater than 0. So it's still positive, but it's less than 1. So that's your coefficient. Just be careful that it impacts on the total expected return. Anyway, the first statement, increase the security beta. If the beta is going up, so any increase in the beta will increase your expected return. So if you are increasing the beta, you should expect that the expected return is going up. So the beta and the expected return are moving on the same direction as long as the beta is positive. And this is the assumption which is mentioned here, the beta is positive. So one shouldn't be the correct statement because we're looking for the option which reducing the expected return. Number two, statement two, decreasing the market risk premium. So the market risk premium, we already talked about this. This is the market risk premium or the MRP. When the market risk premium is going down, what's happening? The whole expected return, you should expect it's going down. So it seems this is the correct statement. The market risk premium and the expected return are moving in the same direction. Statement three, increase in the risk-free rate. Here you have to be careful. Why? Because you see there are two parts of the equation. We have risk-free rate here and here. Now, the risk-free rate here is going up. So this impacts positively on expected return. But since there is a negative sign here, the increase in the risk-free will actually reduces the market risk premium, and in total, the expected return will go down. So one part of the equation impacts positively on expected return. One part of the equation impacts negatively. What is the total impact? That's a question. Remember, your beta or coefficient is less than 1. So it's true that the increase in the risk-free will reduces the market risk premium, but the whole impact on the equation is not as much as the risk-free itself. Why? Because the beta is less than 1. So let's say it's 0.5 or 0.6. So the total impact of the risk-free when it comes to market risk premium is less than the impact of the risk-free rate alone. So in other words, the first portion, the just risk-free here, you see the impact is greater than the impact of the negative MRP. So which means the whole impact should be positive on expected return. So increasing the risk-free rate will increase the risk-free rate here, reduce the MRP, but the reduction in MRP is less than increase of risk-free rate, which means your expected return should go up. So that's why statement 3 shouldn't be correct, because it actually increases the expected return of your investment. What about the last one, statement number 4, decrease in the market rate of return? For sure, the market return and the expected return on the asset are moving on the same direction. As you see, this plus RM, so which means that decreasing the market rate of return also will reduce the expected return. So statement 4 also should be correct. So if you look at the options, E should be the correct option here, because it talks about the statements 2 and 4. Let's move to the next question. So question 2, in this question, we are looking to calculate the expected return on portfolio. Our portfolio has 2 assets. One is the risk-free asset, and we know that the expected return on this asset is 5%, and we have also risky asset with the expected return of 15%. We learned that the expected return on the portfolio is based on the weighted average of individual assets return. So if you're talking about the expected return on a specific portfolio, it should be the weight of asset A. So let's assume asset A is your risk-free asset, so times 5% plus what is the weight of asset B, so WB times the expected return on asset B, the risky asset, which is 15%. So we need to have the weights for assets A and B, which are not given. However, we know the portfolio's beta is 0.9, and we also learned that the portfolio's beta is the weighted average of individuals beta, individual assets beta. So in this case, I can say that 0.9, the portfolio's beta, should be the weight of asset A, which is the risk-free. Now, the risk-free asset, we learned, has the beta of 0. So the risk-free asset has the 0 beta. So that's the only tricky point here. So in other words, the first portion is not relevant. So I can get rid of that. And the weight of asset B times the beta of asset B, which is 1.2. So from here, you can say the weight of asset B is just simply 0.9 divided by 1.2. So we can find the weight of asset B. So let me just divide 0.9 by 1.2, and I get 75%. So 75% or 0.75 That's the weight of asset B. So you're investing 75% of your money on asset B, which means you have two assets. The rest, 25%, should go to asset A. So the weight of asset A is 25%. Now we have the weights. Let's go back to the original formula for the expected return of the portfolio. So this is the 25% expected return, or the weight of actually asset A. What is the weight of asset B? Is 75%. Now, based on this, you can calculate the expected return on the portfolio. So let me do this quickly. 25% times 5% plus 75% times 15%. So the number I have here is 12.5%. So the expected return on the portfolio is 12.5%, which means the correct answer should be A. So it was a kind of two-step process. First, we're required to calculate the weights using the portfolio's beta, and then we use the portfolio's expected return formula to find the expected return on this portfolio. So let's look at the next question. Stock A and G has a beta of 1.1 and expected return of 8%. The risk-free rate is 3% and the market risk premium is 4%. Now, we talk about the overvalued, undervalued stock, and we mentioned that we can compare the expected return based on the CAPM and the expected return which comes from the cash flows of the company or from the dividends of the company. So we have two set of data here. So let me just go and use the CAPM to find the expected return on this specific stock. So what's the formula again? The risk-free rate, which is 3%, plus the market risk premium, which is 4%, times by the beta, which is 1.1. So the second portion should be 4.4%. So the expected return based on the model, which or the CAPM, should be 7.4%. So that's what the model is estimating or actually expecting, 7.4%. But here it's saying we notice that the expected return is actually 8%. So you are comparing the rate of return 8% versus what the model is estimating 7.4%. So what you're actually getting is greater than what the model is estimating. So you're getting more than what the model is telling you. In other words, if you remember the CAPM argument and the SML, you're above the line. You're above the line. So the alpha is positive, which means the stock is undervalued. So the 7.4%, as you see, that's the expected return based on the CAPM, and the 8% is what you are getting. So it means the stock is undervalued, which means C is the correct answer. So let's look at the last question. A portfolio of securities is beta 0.8, and we know the 0.8 is greater than the market beta, which is 1. 0.8 is less than the market beta, which is 1, and greater than the risk-free assets beta, which is 0. Now, let's see which argument is correct for this one. Adding another security to the portfolio must increase the portfolio beta. We don't know for sure. It depends on the beta of new asset. If the beta is less than 0.8, it will reduce the portfolio's beta. If the new asset has the beta greater than 0.8, it will increase the portfolio's beta. So A is not correct. B, the portfolio has more risk than the risk-free asset, but less risk than the market, which is correct. As I mentioned, the 0.8, it means greater than 0 and less than 1. So it's riskier than the risk-free asset, but less riskier than the market. So B should be the correct answer. Why not C, D, or E? C is saying each of the securities in the portfolio has more risk than the average security. We don't know that. It depends on the beta of each security. The beta of the security might be greater than 0.8 or less than 0.8. We can say the average or the weighted average of these portfolios are 0.8, but we cannot judge regarding the individual assets beta. The portfolio has 80% more risk than the risk-free security. It's not correct. You're comparing 0.8 with 0. So it's not 80% more, it's actually not comparable. The expected return on the portfolio is greater than the expected market return. So since your beta is less than the market, the expected return on the portfolio should be less than the market as well, not greater than the market. That's it for today. Thank you very much. Have a wonderful day. Here is Ali Talibi. Stay safe. Take care. Talk to you soon.